So, hello everyone. Welcome and good afternoon, good morning, good evening, depending on where you are, to today's webinar titled Streamline API Provisioning Across Multiple Environments with the APIIDA API Control Plane, the fourth episode of our webinar series on Federated API management. Before we start, let me briefly cover some logistics as always, just to make sure your lines are muted until the end of the session, at which point you can virtually raise your hand by clicking on the raise hand button in the Zoom client, and we'll unmute your line so you can ask questions live on the phone, so to speak. Alternatively, you may ask questions anytime throughout the session using the Q&A module of the Zoom client, and we'll try to answer them either throughout the session or at the end. And as usual, we're recording this session and make it available on our website at apida.com/webinars. So for those of you who can't attend live, or your colleagues who can't attend live can listen in later, and of course you can share it with your colleagues and friends, right? So now let's get started on our topic for today: Streamline API provisioning across multiple environments with the APIIDA API Control Plane. Let me hand it over to APIIDA's CTO, Markus Müller, who will cover today's topic. Markus, over to you.
Yeah, thank you, Armin. So welcome from my side as well. As Armin already said, today we're talking about API provisioning. And the first question we must answer is, well, what is API provisioning in the first place? You might have heard also the naming of API publishing. And what is meant is the process of making an API available to the outside world. So in this very little example, we have a backend that does expose an API. We want to expose that API on the internet. And as we all know, you never do that directly. You always use an API gateway in between for security reasons, but also for other reasons, as we will see in a minute. And that means that there needs to be some piece of software running on that API gateway that takes the request from the outside world, does something with it, and then just places the call to the backend. And that is what we call an API proxy. And the process of creating such an API proxy, that is what we call API provisioning. So if you look at the picture on the slide, the left-hand side, everything from the backend until to your gateway is what we call the publishing experience. And everything on the right-hand side, so a consuming application that is actually calling your APIs, that is receiving data, that is the consummation side of things. So that API proxy that we are about to create in that provisioning, in that publishing step, what exactly does that mean? An API proxy is an abstraction, a little piece of software that is put into the API gateway, that is executed within the API gateway, and that is used primarily for security reasons. So you don't want to have data exposure happen. You don't want to be, you don't want denial of service attacks to be run against your real backend, because even if you can't prevent a denial of service attack, and let's say your API gateway goes down, your backend does not, because it's protected. There's no direct connection between the internet and your backend. So let's say your backend is SAP, and you're running your whole operations through your SAP ERP system. You never want that to be directly exposed to the internet. You never want it to be the target of a denial of service attack. You never want your SAP system to go down, because then your manufacturing will go down, customer services will go down. Basically, your whole company shuts down. So you put that gateway in front of it, and that part of the gateway that actually checks all the incoming requests for this backend, this is called the API proxy. And what can such an API proxy do? Well, it can check a few different things. So first, is that customer or that consumer is authenticated? So do I know who it is who's posting the call? Do I know the application the call comes from? Do I know the user on whose behalf the call comes from? And is this user, is this consumer authorized to use this API? Is he authorized to get this kind of data. So for example, you have your customer service application, and that customer service application requests a customer record. Now, is the user that's logged into your customer service application actually authorized to see these user data, to see these customer data? So that is something that you can check at the proxy level, keep it out of all the backend systems, and just make it or do these checks in the first layer of protection. Of course, we can check if that request is valid. So all of the APIs, if you have been following our webinar series, you know that every API has a contract, has a specification that exactly describes how calls to this API have to look like. So is that request that we just received, is it according to that specification? And that is something that our API proxy can check. And of course, we can check for any number of other attack vectors we know. So we can have a look at all the data passing through, and we can scan it for security vulnerabilities. So we can scan for things like code injection, SQL injection. We can take out all of these malicious requests at the proxy level, at the gateway, so that they never even reach the gateway. So our goal here is basically that every request that hits the backend is a valid one from an authenticated and authorized user and has no malicious content in it. So that's our goal here. But a proxy can, of course, do more. So for example, your backend has a SOAP style API, but you want to expose a REST style API, because honestly, especially if you're working with mobile developers, they're not very keen to implement SOAP style APIs. So these proxies can also do transformations. They can do conversions from JSON to XML or any other transformation you would like to. You can query additional data. So for example, if you have to query a first data source and then use these results to query your backend, then you can do that within the proxy. And of course, you can only forward the needed data to the backend, and also the needed data in your response. So you can strip out anything that is of no need. So for example, if your backend response contains some sensitive data that you don't want to give out to via the API, then you can strip the data in there. So these different steps of processes, they are called policies or assertions. So that is depending on the type of gateway you are using. So let's talk about the act of provisioning an API. The initial provisioning, so creating that API for the very first time, this is usually something that's done in a manual process. So on the right-hand side, I have put some two screenshots from different systems. One is Gravity, one is Broadcom Layer 7. And basically they have their interfaces where you define or are able to define your API proxies in a visual manner. Because that is quite time consuming, and because a lot of companies have services that look and feel similar to each other, a lot of them use templating languages to bootstrap that process. So you're not instantiating that service, that API proxy directly, but you use some templating system. And most of these times, these templating systems are custom built. So, you know, they had the case for repeating API proxies. Someone went ahead and built a system for it. It got maintained for some time. It grew, and now it's there, fully custom, not out of the shelf software mostly. That is what we find with our customers. For Broadcom Layer 7, we do offer a standards-based out of the shelf templating system, for example. But again, most customers that we work with have something that they build from the ground up. And as we will see, that is creating some problems down the road. And what you end up with after you have done this provisioning is that you then extract your API proxy back out of your gateway to have it as code. And in some systems, you can also find the name of policy as code for that. The basic idea is that you want to have everything as code nowadays. So the next step, after you successfully provisioned your API proxy, is that you want to have some automation. Because the proxy changes whenever there's either a change of the backend API, some of the identity providers you use for authentication or authorization change, there are some new rules or some new guidelines that need to be enforced, or there are some new transformations that need to be done. For example, your backend now returns more data, but you don't want to return more data with your API, so you need to strip that data. And that basically means that this definition of a proxy is a living document. So it's not something you do once and then forget about it. So it lives, which means you have to version it. And you should version it either in its own repository, like every piece of code that you work with, or you can also put it into the backend's repository, because that proxy and that backend, they belong together. Unless, of course, it's an orchestration thing where in one proxy you query multiple backend services. And if you're interested in how to achieve this, how to achieve that automation, make sure to have a look at our YouTube channel or our webpage, because we did a whole webinar series only on API ops. So that's the name of it, right? So automate your API operations. So that means it isn't that hard, right? Is it? So quite straightforward until now. But what is the problem now? So what are we talking about today? In reality, your API landscape probably looks like something like that. You have a whole of different systems that might talk to each other. Some do, some do not. You might have multiple API management solutions in place. And you have a lot of different other systems connected, design tools, mock backends, and so on, and so on, and so on. So the task is not as easy as we just described. Especially if you have more than one data plane. And a data plane is what we call that part of your system where the requests are actually handled. So you might have an API gateway that's connected to some backends on premise. You might have a second API gateway connected to some systems in the cloud, or even a third one, a cloud native one that just is used for workloads, for example, in Azure, in AWS. And that basically creates a few problems. Because now every system has its own templating language. So your on-prem API gateway might be from a different vendor than the one in the cloud, especially if you're using one of the cloud native ones, because the basic gateways of AWS, Azure, Google, and so on, they just work with Azure, AWS, and Google workloads. So if you have any other workloads, maybe running in a hybrid approach, then of course you have a second API gateway with its own language. Also for versioning, some API gateways do have versioning, some haven't, some use local revisions, some use global versions. So basically what you end up with is you have multiple processes for the same problem. We just want to provision APIs, but now we have to know, where does this API go? Will it go to this gateway? Will it go to this gateway? And then we have to use a different process. We might have more scripts running, so we might end up with multiple in-house systems that we now have to maintain. And of course, if I have to decide prior provisioning on what API gateway, on what platform my API goes, that means I can switch runtimes later on, right? So I cannot say like, oh, now it's running on Azure. I want to have multi-cloud approach, and this workload I would like to move from Azure to AWS because, you know, I want to distribute my operational risk. You can't do that, right? Because the scripts you wrote, the proxy you created, it will only run on Azure. And this is where we come in now. So what we reckoned is that in a landscape that is so heterogeneous, like the API landscape is in many, many companies, there needs to be one single source of truth. And that single source of truth must take care of all the things that, in our eyes, are strategic to API management. So there are a lot of things that you might replace where you might use different systems depending on your use case, depending on the deployment approach. So for example, every team might want to use a different design tool. Not everyone is happy with the design tools that come with the API gateways. Some teams prefer Postman, some teams prefer something else from another vendor. So be it. Let them use whatever fits their process best. Let them use whatever creates the best APIs. And again, as well for the gateway, as I said, you might have some on-premise gateways. You might have some cloud gateways, and it doesn't make a lot of sense to bring an on-premise gateway into the cloud if you only want to proxy one single use case on your cloud. Or for example, if you are running serverless, it doesn't make a lot of sense to have serverless services that are then sitting behind a non-serverless, a classic server API gateway. So that is something where you can choose the best thing, the tool that gets the job done. But for everything that needs such a single point of truth, as we will see, you need to have that one core. So you need to have one element that is responsible of discovering all your APIs, of provisioning all your APIs, of securing all your APIs. And what we have there is we do this with a multi-plane architecture. So if you're not familiar with multi-plane architectures, there is a management plane, which basically defines configuration, manages your processes, and that management plane doesn't need to know about the data planes at all. As you can see in this picture, we have analytics, we have access policies, we have global config. You can define all of that without knowing what data plane will be executing the request. Then we have the control plane, which takes care of security, traffic shaping. So how do my traffic policies look like? Are there any rate limits? Is there throttling? For that, of course, you need to know how to translate that to the different data planes. But you can define that in a way, as we will be seeing, that is independent of the data plane. And API provisioning is living in that management plane and in that control plane. So if we take this generic architecture, you can find that in many, many places in IT, network administration, cloud administration, they all are built upon those same principles. If we apply that to API management, it looks something like this. So we have taken the management plane, the control plane into one because they overlap a lot. So you have a developer portal there, an administration portal, and that talks to one or multiple data planes. And this architecture is called Federated API management. And this webinar series is based on Federated API management. So again, the idea here is you have some centralized management, some single point of truth, but the processing of your requests is federated. You can control the different data planes. You can provision to the different data planes, no matter where they are running, what technology they are running, because in that moment, you don't care. You care about your API being published, being provisioned, not how it is done. You're just content with that it is done. And how it is done, that is where the control plane comes in, as it does all the necessary transformations to get you there. So what are your next steps? What can you do now to get that streamlining of API provisioning underway? So first step, of course, replace the existing in-house tools with out-of-the-shelf products. That might be counterintuitive, but the reason is very simple. When you build these in-house tools, you had a certain use case. Now, your use case might have changed, or your API management solution that you're currently using might have more functionality than it did have when you built that. And that added functionality, that added developer experience is basically something that you cannot use because your in-house tooling doesn't support it. And of course, new versions of the API management platforms come out and you have to maintain them. You have to update your in-house tooling. And this is an even bigger burden if you're not maintaining one set of scripts or whatever you created for one API management platform, but multiple scripts for multiple API platforms. So we're talking here about an exponential growth in maintenance effort. And as we all know, things start to break the moment that really doesn't fit any of your schedules, right? When you have a really big backlog, everyone is screaming for more manpower. It's then when those tools are breaking. So replace those with out-of-the-shelf templating solutions that can create APIs through your CI/CD pipeline in an automated fashion, that can create APIs for different versions of these API management solutions. So to just relieve you of the burden of having to maintain that. And you always know if there is a problem, there's someone I can call. And because I paid them, they have the time to do so. The next step, of course, is define your API proxies in a vendor-independent way. And this is quite a no-brainer, but honestly, if you're looking on the market, there isn't a solution like that right now. So just define your API proxies, specify the authentication, transformation, whatever data you want to strip, define it in a vendor-independent way, and then transform it into whatever the different platforms require. The benefits, they are no-brainers. So you prevent vendor lock-in, right? So you define it in a vendor-independent way. If you want to change vendors, if you want to switch vendors, if you want to migrate to another platform, do so. As long as that platform understands that specification, you're fine. The other big benefit is that there's only one process now, because it doesn't make a difference if it's finally or eventually deployed to one platform or the other platform. The transformations are handled for you. All you have is, I have that vendor-independent specification, I put it into my process, I tell it where the API proxy should be created, and off the system goes and creates that proxy there. So one process, one workflow, one documentation, because as we all know, the more documentation we have to write, the wronger it will be, right? So I don't know any documentation that really is correct to the last sentence. And the more you have of it, the more you have to describe, the more processes that are moving. As I said, the versions change, the updates are coming, new features are coming, so you have to keep the documentation in sync. It's hard for one system, it's even harder for two. Don't get me started on 4 or 5. So one process, one workflow, one documentation, one way to do things, one way to troubleshoot things, one way to debug things. And of course, that is expandable. So you're using 2 systems today, okay, make it 3 tomorrow. Maybe there is some IoT use case where you want to use a specialized gateway. Maybe there is some event-driven system that you want to bring in. No problem, define your proxies in a vendor-independent way and get your system running. And that vendor-independent provisioning is what we are currently working on. It will be available in 2023. But you can, we will do some more videos on the current stage of the system to show you that it actually is working, that you can use it today. And the idea behind that is what you may be knowing is the Open API initiative and the Open API specification. And that Open API specification contains everything that is needed to consume an API. So what endpoints does the API have? What payloads does the API require? How do the responses look like? What the Open Proxy spec does, it does the same, but for the publishing side. Again, remember the first slide, the publishing experience, the consuming experience. Now the Open Proxy spec is about the publishing. So what authentication is required? What are the identity providers the requests have to be checked against? Where is the authorization stored? How does security look like? What transformations need to take place? So all of that is in the open proxy spec, and our API control plane then takes this proxy specification, transforms it into the system that you are using, the language of the system that you're using, and provisions it directly on your gateway. So you just plug in the API control plane into your CI/CD pipelines, into your automations, you're provided with the open proxy spec, and then your API gets provisioned, or if it was already provisioned, it gets updated, you get the versioning right? So you get all the benefits that you would take for granted, but as we've seen in the introduction, a lot of the systems don't even support that. So you need a system on top of that that makes sure there's support of it, it is consistent, and if this platform itself doesn't support it, then the system above does. So again, only one process, one workflow, one mental model to take care of. So that brings us to the wrap up. API provisioning and keeping your APIs up to date to the changes in the backend is a time-consuming and error-prone task. And as we've seen, that problem is amplified when using multiple API platforms. And make no mistake here, you might think that you nowadays have only one API management platform, but I'm quite sure that even if you have only one right now, you will have multiple in the future. Just think again about the move to the cloud. Just think again about new types of workloads, being it IoT workloads, any other kind of workloads. The API gateway itself is becoming a commodity. We see more and more and more API gateways pop up in the market. And every API gateway that there is has one very specific feature, one unique selling point where it's really good at. Probably you won't find one gateway that can do it all. So they all have their individual strengths. Now, if you are running a solution like the API control plane, that means you can choose those gateways based on their strengths. You don't have to go for the smallest common denominator. Use whatever fits the task at hand best, right? So you get the most out of your API program. Everything we do at APIIDA, everything has just one mission. We as APIIDA have one mission: to make your API program successful. And your API program is successful if it works, if you're using the best tools, if you are using experienced people, experienced consultants. That is the easiest way, best people, best tools for the best solutions to get your API program going. As we've also seen, the API management architecture to use is the federated one, because again, with using the control plane, there are no downsides to this, but only the benefits. If you don't have a control plane, then I wouldn't suggest doing federated API management. You will run into problems, and that means these problems will most likely have to be solved with manpower. So more cost, your return on investment cases will not work anymore. So make sure that you invest in a control plane to have a stopgap here and to make sure that everything works as you expect it to. And as we've seen, the control plane does not only support provisioning and migrating within a given platform. That's something that the control plane can do out of the box right now. You can just use the control plane to create an API on one system, move it within the same platform, but it also supports that in a vendor-independent way by using the open proxy spec. So yeah, thanks for listening to me. And I think I now hand it over back to Armin for some question. And of course, we have a new webinar series upcoming.
All right, excellent, Markus. Thank you so much. Now, as said, let's open it up for questions and answers. If you have a question, as said, please press the or virtually press the raise your hand by clicking on the raise hand button in the Zoom client, and we'll unmute your line. Alternatively, please use the Q&A function of the Zoom client. And while we're waiting for questions live on the call. Here are some that came in through out the session. And the first one is, let me read that. How is uniform provisioning across different vendors implemented, especially when a new runtime is connected?
Yeah, so as I said, always do it within your automations. So if you have a CI/CD pipeline, put the provisioning in there, and there you can also define the target. So if you add a new management platform to the mix, you can just adjust the target within your pipelines, and during the next pipeline run is then commissioned and provisioned to that new API runtime. Of course, you have to take care about the phase where either it's running on both systems. So maybe you will want to keep the older version on the old system and only deploy new versions to the new system. Or you have to, what you can also do in the control plane, by the way, to deprecate the old version, give it a grace period, and then sunset it. So that basically depends on how you want that to play out. But the general advice is always put it into some automated approach, and then you can just change the target whenever you add something new, and it gets automatically provisioned there as well.
Mm-hmm. All right, thank you, Markus. Second question I have here is, how is the different data that is available in the different runtimes handled when unification takes place?
Yeah, so the different data, and that mostly comes down to configuration items. There are some common classes, right? So every system has some concept of an identity provider. It might not be named identity provider, but there is a concept like this. Also, every system has the concept of variables. Might be environment variables, might be cluster variables, all different kinds of variables. And so there are certain classes of configuration items that are present in all the systems. So of course, you can target that in a vendor-independent way. The control plane takes care of translating it into the format that is required. Then there might be some things that are only present on one of your environments. So for example, let's take Broadcom Layer 7 that has an integration for XMPP servers. Okay, I don't think any other API management gateway out there has such an integration out of the box, maybe with plugins, but not out of the box. So in that case, you can add vendor-specific customizations to the proxy spec. So you can extend that generic proxy spec with something that's vendor-dependent. Of course, then you cannot switch the runtime anymore because you're using a feature that's only available in one of your systems. But you still have the benefits that your process stays the same, the language in which you describe it stays the same, your workflow stays the same. You still don't have to maintain any of your own tooling. But of course, if you would like to use something that's explicitly only available on one platform, then you limit yourself on that one platform. And if you want to switch that service, that API to another platform, then you have to do so manually by figuring out how to do that in the other system.
Mm-hmm. Okay, thank you. Just as a reminder, if you have any questions that you want to ask live, you just press that raise hand button and then we'll unmute your line. I said alternatively, please continue to use the Q&A module of the Zoom client. And the next question, Markus, is can I do the same with an on-prem gateway, I guess, as compared to a cloud gateway, or are there limitations in provisioning?
No, there are no limitations. For the sake of provisioning, all of these systems work basically the same. They all have the capability of importing some kind of proxy definition. The format of that is different from system to system, but that's mostly divided into newer systems and older systems. So for example, systems that are longer in the market, like Broadcom or like APIIDA, they have an XML-based format. Newer things like Kong and Gravity, they have a JSON-based one. There is no difference between on-prem gateways and cloud gateways. And the way that the control plane works is by putting a little agent next to your gateway. So from the control plane's point of view, there are just gateways connecting, and the control plane doesn't care if it's an on-prem, if it's a cloud, if it's a hybrid or whatever, right? So for the control plane, every gateway looks the same way. So there's no different level of support or no different level of functionality between on-prem or cloud.
Okay, excellent, thank you. And currently the last question I have here is to what extent are changes made to the gateways as part of provisioning when the control plane functions as the leading system?
Depends. Generally speaking, the configuration is not changed. So for example, if you create an identity provider within your API management platform, the control plane will not change. It will not alter it. It will not try to delete it, create a new one, whatever. What is possible is that, of course, you might have environment-specific configuration. So, for example, you might have it's kind of a translation table where you tell the system, okay, if you are running in this environment, please use the identity provider with this name. And if you run in this environment, please use the identity provider in this name or with this name. So for example, if you have like development, test, production, of course, you need to rewire your API because you don't want to talk to your production databases in development and so on. So there is some, I'd say, some configuration happening of the proxy itself, but we do not alter the configuration of the management platform, because usually you have much more fine-grained control over the different entities in the platform itself, and configuration, at least that kind of configuration, is usually not changing so much. So if you have set up your identity provider and you have like 5 million customer data sets in that, you don't change that twice a week, right? So you change that maybe once every 5 years, but that's it. So these kind of things are not touched. Whatever you have configured stays the same. The control plane doesn't alter that. But of course, if the proxy needs to reconfigure it because there are some guidelines on the environments, there are some constraints, then that will happen.
All right, perfect. Thank you, Marcus. And now, before we close, let me just point out, as Marcus said, we have a new webinar series coming up, or we'll continue the series in next calendar year. We have a new concept. We'll be switching to webinars on demand. So the dates given here are from that date. You can then listen into those webinars at whenever you want to, basically. And we're going to start that series with different use cases and how to solve them using the API control plane. We're going to start from, as I said, January 18th with the use case of moving to the cloud and how to solve that. In more detail, it was briefly mentioned again today, but we'll spend way more time on how to do that using the control plane. We'll continue with unified API catalogs from February 18th and branch jobs and unified infrastructures from March 1st. And there will be more in Q1, right? So again, thank you, Marcus, for walking us through the session today. And thank you all for having joined us. As mentioned before, we will make the recording of this session available on our website, apiida.com/webinars. And we hope to see you all again soon, hopefully at API Days, for example, next week in Paris, where we will be one of the exhibitors. We'll be hosting a workshop on federated API management. Marcus will be doing a talk, and obviously you can take a first-hand view on the API control plane during demos and sessions at our booth. So thank you very much, and see you soon. Thank you so much. Bye-bye.